here. So to continue our discussion on 9.3, one of the application type problem, horizontal distance d in feet traveled by a projectile launched at angle theta with initial velocity v in feet per second is given by d equals v squared divided by 32 times sine 2 theta. Estimate the horizontal distance by a golf ball that is hit at an angle of 50 degrees, meaning theta, and initial speed of 100 feet per second, that is our v. So d, we're trying to find, is equal to v squared, or 50 squared. I'm sorry, not 50 squared, 105 squared. Okay. Over 32 times sine of 2 times 50. So 105 squared, what's that, 11025, yes? Over 32 sine 100. Everyone knows how to do this in your head, right? 105 squared. How far away from 100 is it? 5. So you add 5 to 105, you get 110, and then 5 squared is 25. That's how you do that. Yeah, it's pretty sweet, I know. So like 107 squared is 11449. 108 squared is 11664. 120 squared is 140, but then you have to square it, and then it becomes 400, and then you have to carry it, so it gets a little tougher, but it's awesome. You can do that stuff in your head. Anyway. Okay? Anyway, what does this equal? $339.3. That's an approximation, right? Okay. So if we round it to the nearest foot, it'd be 339 feet. Okay. Good. Just applying those formulas, right? Whether you like golf or not. Okay. Aaron doesn't. Oh. Aaron, are you out there calculating it, like before you hit the ball? It's a good point. Yeah, no one looks at feet in golf. Okay. Hey, on Friday we left off with problem number 6. So our last lesson there, we actually finished that problem, I believe, but it was like way fast, and some of you looked like you were just kind of trying to keep up there. So I want to go back to this problem, number 6, which said I want to find the reference angle of 27 pi over 10. Okay, this was on page 256 of our student journal. Okay, so I'm going to re-sketch that problem, number 6, 27 pi over 10. Okay, and we're supposed to find its reference angle. All right. So, once again, that was page 256 of Student Journal. So, not spending tons of time on it. First thing we need to do is recognize that when we're dealing with one complete revolution, how many pi is that? 2 pi. Okay, one revolution is 2 pi. Now, 2 pi in terms of tenths is how many tenths? Just multiply 10 by 2, you get 20. So it's 20 pi over 10. That means for every 20 pi over 10, we went a revolution. So 27 pi over 10 means we go. There's one revolution. We've traveled how far now? 2 pi, which let's not call it 2 pi anymore. Let's call it 20 pi over 10. Anytime you want to change a decimal, by the way, to be in terms of a certain denominator, just multiply how many you have by the denominator. So 2 pi times 10 is 20 pi. If I wanted to change it to thirds, I would go 2 pi times 3, which would be 6 thirds. That's still 2 pi. Okay? So 20 pi over 10. That means every quarter of a turn is how many? So like if I keep going here, how far have I traveled now? I've traveled, in terms of tenths, I've traveled 5 pi, right? So that I've now went 20 plus 5 or 25 pi. So every quarter is 5 pi over 10. Okay, I've went 25 pi. Do I need to go, this would be 30 pi, right? Can't go over that far. So I go just almost a half. There is 27 pi over 10. Now to get to here, I need to go 30 pi, which is how much farther? Yeah, that is 3 pi over 10. That is its referencing. Okay? Pay attention. Questions? Yeah. No, that is the angle in terms of radians. Yeah. Okay, one last problem on that page was number 7. Evaluate the function cosecant 150 without a calculator. Okay, cosecant 150. So first thing I start doing, just to help me out, I sketch a 150 degree angle, which here's 90, here's 180, 150, about right there. How far from 90? Or excuse me, from 180? 30 degrees, okay? So that would be a 30 degree angle. That's the reference. Now I'm thinking of my coordinates. What are my coordinates? Well, think back to here. A 30 degree angle over here is root 3 over 2, comma, 1/2. So over here it's negative root 3 over 2 and 1/2. Y doesn't change. Now if I'm dealing with cosecant, cosecant is what over what? Is it related to sine or cosine? Sine. It is 1 cosecant 150 is equal to 1 over sine of 150. Well, which one's sine? X or Y? Y. Because, that's why. Okay? That's sine. This one's cosine, remember. So I can replace cosecant 150 is actually 1 over, not sine 150, we know sine 150 is 1/2. What is 1 over 1/2? What's 1 divided by 1/2? How many halves in 1? 2. Value is 2. That is the exact value. Thank you. Okay. Any questions? Yeah.
How would you do it if it was an angle that, or like if it was 105?
105, we have to use other. Yeah, you guys, if it's not a special angle, there are other properties we use. You just haven't learned them yet. Angle sum identities, angle difference identities, we use all that stuff, but that's later in the chapter. Right now we're dealing with just the special ones. Okay? All right. Hey, last thing I want you to do I'll be handing out your assignment while you're doing this, but you need to take the unit circle. I'm not going to walk through how to do it again. If you need to see that, go back to one of the previous video lessons and watch it. But I want you, without peeking at any other unit circles, complete it. I will put the answer up there here in a few minutes. Okay, let's check your work here. I'll zoom into the first quadrant there. All the triangles drawn in there still. You don't have to have those, but okay. Might be a little tougher to see, but here's your radians for that quadrant. And this should be a 0 degree. Okay, second quadrant. Again, don't forget about your radians. They're the rad part. Third quadrant. Coordinates go negative, negative in that quadrant. Just reflecting from previous quadrants. And the fourth quadrant. So we're now at a positive, negative radian.